Download this code from codegive.com, link in the description below. Tutorial on 7-1-3 Gradient Descent for Linear Regression. Introduction to Gradient Descent. Gradient descent is a popular optimization algorithm used in machine learning to minimize the cost function by iteratively updating the parameters, weights, of the model. In linear regression, we aim to find the best fitting line through the data points by minimizing the difference between predicted and actual values. The gradient descent algorithm consists of the following steps. 1. Initialize parameters, weights, randomly or to 0. 2. Compute the gradient of the cost function with respect to the parameters. 3. Update the parameters in the opposite direction of the gradient. 4. Repeat steps 2 and 3 until convergence or for a fixed number of iterations. The learning rate determines the size of the steps taken towards the minimum. A too large learning rate can cause overshooting, while a too small one may slow down convergence. Overview of the 7-1-3 gradient descent approach. The 7-1-3 gradient descent refers to a specific strategy in tuning the hyperparameters during the optimization process. 7. Number of iterations to perform the gradient descent update. 1. Learning rate, which controls how much we adjust the weights per iteration. 3. Number of features in the dataset. For simplicity, we'll work with a 3-feature dataset. Steps in the tutorial. 1. Set up the environment, import necessary libraries. 2. Create a synthetic dataset, generate data for linear regression. 3. Implement gradient descent, write the function to perform gradient descent. 4. Train the model, use the dataset to train using gradient descent. 5. Visualize the results, plot the data and the regression line. Code example. Here's a complete implementation of the above steps in Python using NumPy and Matplotlib. Explanation of the code. 1. Dataset creation. We generate a synthetic dataset with 100 samples and 3 features. The target variable y is a linear combination of the first feature plus some noise. 2. Cost function. The compute_cost function calculates the mean squared error, MSE, between the predicted values and the actual target values. 3. Gradient descent function. The gradient_descent function iteratively adjusts the parameters, weights, using the gradient of the cost function, updating theta based on the learning rate and the computed gradients. 4. Training the model. We initialize the parameters randomly, set the learning rate to 0.01, and specify the number of iterations as 7. The final parameters and cost history are printed. 5. Visualization. We plot the cost function over iterations and the regression line against the data points to visualize the fit. Conclusion. This tutorial introduced you to the 7-1-3 gradient descent method for linear regression. You learned how to implement gradient descent from scratch and visualize the results. You can modify the dataset, learning rate, and number of iterations to observe how they affect the accuracy and convergence of the model.